Hi, I'm Tushar Menon. I'm a philosopher of physics and I'm visiting from MIT. The project that I'm going to be doing while I'm here at the center is it's around understanding quantum mechanics and understanding what quantum mechanics tells us about the world. Now, if you think about the way people have thought about this until now, they broadly fall into two categories about how we ought to think about what quantum mechanics tells us about the world, or maybe what we can use quantum mechanics to learn about the world. The first way of thinking about things is a little bit like what we do with classical mechanics, right? We've got some system, we associate it with some properties, and we think that the classical properties we associate with them are like actually descriptive of the system, right? I can think of a bridge, I can think of its properties, its mass, and various things, and then I can look at a classical description, and then from that classical description, I can know, oh, right, this is the thing that's being described. This is what the world is like according to this little bit of classical mechanics. And so one way of thinking about quantum mechanics is extending this model, right? This is the so-called realist approach to quantum mechanics, where you just think, sure, quantum mechanics is different from classical mechanics in terms of what it says, but the way in which it tells us about the world is the same. Classical mechanics is about bridges, quantum mechanics is about something else, and then the realist is interested in figuring out what quantum mechanics is describing, right? The analogy that I like to use is, I can read a travelogue about some country that I've never visited and get a pretty good sense of what that country is like. And the reason I can do that is that the travelogue describes that country. And so I can learn about that country by reading the travelogue. And similarly, you might think I can learn about some bit of the world that I'm never actually going to see, namely the unobservable bit of the world according to quantum mechanics, by just looking at what quantum mechanics describes. And that project then is to understand how that works. So call that the travelogue model. There's another way of understanding how quantum mechanics works, which is very different from the classical model. And on this model, you think of it as telling us how to use a particular set of instructions in order to cope with the world around us, right? So to analogize again, imagine I've got a dryer for my clothes. And what it is that I use the dryer for is obviously to dry my clothes. And so I might have a user manual associated with that that tells me what I need to manipulate and what I need to do in order to get my clothes to dry. And some people, the so-called anti-realists, broadly speaking, think about quantum mechanics on this model. They think, well, the world is already populated by stuff, and we might have some other theory about what that stuff is, right? In the dryer example, it's my theory of medium-sized drying goods. And then what quantum mechanics is like is the user manual, right? It's telling us how to manipulate things in order to navigate our way through the world. And broadly speaking, these two traditions have remained kind of separate. And my project while I'm over here is to try to understand the circumstances under which it might be appropriate sometimes to think about quantum mechanics on the travelogue model, and sometimes to think about quantum mechanics on the user manual model. And what I want to do is have a sort of principled way of making this distinction. And I think the key to this is in a bit of philosophy of language that's actually quite deeply associated with Pittsburgh, namely the inferentialist approach to conceptual content that was championed famously by people like Wilfrid Sellars and more contemporaneously by people like Bob Brandom. And so this sort of very nicely explains why the center is the perfect place for me to be visiting right now, right? If you think about the two sort of broad areas of interest that I'm trying to merge, there's interest in the foundations of quantum mechanics. That's what philosophers of physics are interested in, and there are a whole lot of them here in Pittsburgh. But the way that I'm trying to make sense of this is by using the conceptual machinery of the inferentialist pragmatists of the Wilfrid Sellars, Bob Brandom branch, who are also here in Pittsburgh. So if you look at that Venn diagram, it's a sort of bespoke creation. It feels like a bespoke creation for me, this position here at the center. So that's why it made complete sense for me to apply for this position. I'm really glad to be here.